Okay, calculus, we're going to just touch base on a couple limit properties here that are pretty handy to know. The first one is called the limit of the identity function. We call it the identity limit, or the easier one is the limit of x, and it looks like this. This is the graph of y is equal to x. Remember, that is the diagonal, because if I make a table for that equation, y is equal to x, x, y, hey, the table is 1, 1, 2, 2, 3, 3, and so on and so forth, because they are both equal. So if we take a look at, if x is approaching 1 right here, so let's just practice. Let's put in a line through 1. Hey, if I trace the graph, I'm coming in at a y value of 1. And it just keeps going. And it's the same. All right? If you're approaching 1, the limit is 1. If you're approaching 2, the limit is 2. If you're approaching 3, the limit is 3. Okay, so the limit as x approaches 1 of x is 1. It's the same as whatever you're approaching. Okay? The limit as x approaches 2 of x is 2. It's the same as what you're approaching. The limit as x approaches 3 of x is 3. It is always the same as whatever you're approaching. All right, so the identity limit, it's always equal to what you are approaching. If this number right here is just plain old x, think of the graph of y is equal to x. It is the same as whatever you're approaching. So the limit as x approaches negative 2 of x is negative 2. All right? So to recap, the limit is always equal to the number x is approaching. All right? Easy enough. X is approaching. All right, the second property that is pretty handy is just the limit of a constant. Now remember, a constant, you guys, is just a fancy name for a number. All right, a constant is just a number. All right, so my example here is y is equal to 3. All right, here is the graph of y is equal to 3 right here. It's just a horizontal line. Oops, that's a backwards 3. It's just a horizontal line through 3, because the points on the y values on that line are all 3. Okay, this is 0, 3, 1, 3, 2, 3, 3, 3. So the graph of any number is just a horizontal line. And no matter what x value I'm approaching, the y value is up here at 3. So the limit of a constant, the limit of any number, is that same constant, is that same number. Okay, so let's look up here. The limit as x approaches 1 of 3, if I'm at 1, my limit is up here at 3. It's equal to 3. All right? It is the same as this number. They're always the same. Okay, right here. The limit as x approaches 2 of 3. If I'm at 2, my limit is up here at 3. So this is equal to 3. Again, it's the same as what that number is. The limit as x approaches 3 of 3 is 3. All right, it's the same as this. Next one, we just keep going. The limit as x approaches negative 2. That will still be 3, the same as this. Okay, so the limit of a constant is that same constant. If I did a couple others, let's just practice. Okay, what about the limit as x approaches 10 of 4? All right, the limit of a constant is that same constant. All right, let's do another one. The limit, I don't know, as x approaches 1 of 6. All right, the limit of a constant is that same constant. All right, so now we're just going to practice. Number 1. The limit as x approaches 4 of 7. Well, this is a constant, so it has to be the same. All right, and that property is limit of a constant. All right, now you're not going to have to list the properties. I just want you to make sure you know these. Number 2, the limit as x approaches 0 of -9. The limit of a constant is that same constant. So that's just going to be -9. And again, that is limit of a constant. All right, let's keep going. Number 3. All right, so now we have the limit as x approaches 4 of x. So that's the limit of x property. It's equal to whatever you're approaching. So this is 4. All right, when this is x, your answer is right here. All right, and we just call that the limit of x. Or you can call it the identity limit too. Either one is acceptable. Okay? Next one, number 4. What is the limit as x approaches pi of x? Whenever this is just x, think of that diagonal. Your answer is sitting right here. All right, your answer is pi. And of course, that is the limit of x, the identity. All right, now don't worry, you're not going to have to list out properties. I'll never make you do that this year. All right, here we go. Let's keep going. Number 5. Now we have a limit problem. Go through your steps. Can you do direct substitution? Can I plug 5 in right here? Absolutely, because it does not cause me to divide by 0. So -6 times 5 is equal to -30. Number 6, a limit problem. Can I do direct substitution? Can I plug in 5 for x? Absolutely, it doesn't cause me to divide by 0. 12 minus 5 is equal to 7. Number 7, I have a limit problem. Can I do direct substitution? Can I plug in -1 for x? Well, first let's check the bottom. So let's check. 3 times -1 to the 5th plus 4. All right, so -1 to the 5th, if this is an odd exponent, this will always be -1. So that gives us 3 times -1 plus 4. That gives me -3 plus 4. That gives me a 1 on the bottom. So I can do direct substitution. So now I go ahead and plug it in on top. -1 squared plus 1. That gives me 1 plus 1, which is 2. My limit is 2. So just because there's a fraction doesn't mean you can't do direct substitution. You've just got to check. But here we can. The limit is 2. All right. Number 8, I have a limit problem. Can I do direct substitution? Absolutely. I just plug it in. 6 times 2 squared plus 2 times 2 plus 1. I just plug in 2 everywhere I see x. So 6 times 4 plus 4 plus 1, 24 plus 4 plus 1. Well, there's a fun number, 29. To check your answers, hey, you guys can graph these and look at your table or look at the graph. Okay, last one. We have a piecewise function. Remember, a piecewise function is just parts of a function, and they each have their own domain. So for this part of the function, x squared plus 5, it's all x's less than 2. Now think of a number line. Less than 2 is to the left of 2. So this is going to be my left function. All right, 2, you guys, is called the dividing point. This part of it, 3x plus 1, that's a line. That's domain is x is greater than or equal to 2. Greater than 2 on a number line is to the right of 2. So this is going to be my right function. Okay, so now I just go to work. Here, down here, the limit as x approaches 2 from the left. Remember, that little minus sign means from the left. So I'm going to use my left function. My left function is x squared plus 5. So I'm going to plug in 2 for x squared. So 2 squared plus 5. All right, that's giving me a 9. So my left limit using my left function is 9. Now here, this is x approaches 2, that little plus sign right there. That just means from the right. So I'm going to use my right function. Alright, so I'm going to use 3x plus 1. So I'm going to plug in 3 times x plus 1, and I simply plug in 2. Alright, so 3 times 2 is 6, 6 plus 1 is 7. So my right limit is 7. Okay, now the left limit is 9. The right limit is 7. So what is the limit as x approaches plane old 2? Well, the left and the rights are different, so that is D and E. Alright, the left limit is not equal to the right limit. Alright, there you go, calculus. Keep in touch. Let me know how you're doing. Thanks for listening.